Hello, today's lesson is 4.2. We're going to be talking about determining the slope and y-intercept. So let's get started. Okay, as I said, determining slope and y-intercept, the standards you're going to work with is I can determine the rate of change and the beginning value, and I can derive the slope-intercept form of an equation. And it's going to be very important for a while, being able to develop these equations and finding slope and y-intercept. You have two standards with this, standard 8F4 and standard 8EE6. F4 is construct a function, that's what a linear equation is. To model a linear relationship between two quantities, determine the rate of change and initial value of the function from a description of a relationship or from two xy values, including reading those from a table or from a graph. Some of this you've done, so that should be a little bit familiar. Interpret the rate of change and initial value of a linear function in terms of the situation it models and in terms of its graph or table of values. Be working on this for a while. EE6 use similar triangles to explain why the slope m is the same between any two distinct points. We're not going to worry about the triangle part yet. We're just going to worry about the slope on any non-vertical line in the coordinate plane, and derive the equation y equals mx from a line through the origin and the equation y equals mx plus b for a line intercepting the vertical axis at b. So we're going to be talking today about the y equals mx plus b part. I'm going to minimize myself so you get the whole screen to yourself there to see, and let's begin. What is the slope-intercept form? And this guy says me, y equals mx plus b. So that's awesome because that's what you're going to be doing. Okay, let's review the y-intercept. Y equals mx plus b. B is the y-intercept. What does that mean? The y-intercept is where the line crosses the y-axis. That's the up and down line. So here's a graph. Y is up and down, x is left and right. Okay. Notice that the y-intercept, the b, is at the point 0, 0. So the y-intercept is 0 there. A proportional relationship will have a graph that crosses the y-axis at point 0, 0. So it will always be proportional if it crosses 0, 0. So that's a proportional relationship. A proportional linear equation has no b, because it is 0. B is 0 at that point, so there will be no b. It'll just be y equals mx. And that's what we started with module 3, talking about y equals mx. We didn't have the b yet, because we were talking only about proportional relationships. And now we are talking about non-proportional relationships. So that is y equals mx. A non-proportional relationship will have a y-intercept of some number because the graph of the line has shifted up or down from the origin. So it's a shift. A shift is a move in the line. So it normally is at 0, 0, and you're going to learn all about different graphs, probably more next year, how they can shift and move. You're going to learn some of that this year, but graphs will that are not at the origin have shifted, and your equation will look a little differently. So let's see what that looks like. So here now the line has shifted up. Notice how it's no longer at 0, 0. Spotlight here. So here's 0, 0. So it's moved up, right? It's no longer at 0, 0. So that is a shift. You now have a B. The B is where it crosses the y-axis. So it happens to be right at this point. What is that number? Well, it depends what our scale on our graph is. If it goes by units, it'd be 1, 2, 3, 4, 5. That would be our B. So that is a non-proportional relationship because it does not go through 0, 0. A non-proportional linear equation has a B. It will always have a B, a number that comes after the plus sign or the minus sign. It will, by the way, this plus sign means the graph has shifted up. If it was minus b, that would mean the graph has shifted down. So that is y equals mx plus b. The x-coordinate at the y-intercept. What is it? Well, what is the x-coordinate at the y-intercept? Do you know? Let's take a look at a graph. Let's put the x-coordinate at the y-intercept is always 0. For example, if the y-intercept is 0, then the y-intercept point will be 0, 0, right? There is our proportional relationship. This is 0.00. The y, it crosses the y-axis at 0, and this is also 0 for x. Y-intercept 0.00. If the y-intercept is 2, then the y-intercept point will be 0, 2. See how that looks. Here it's crossing the y-axis at 2. Okay, but notice how x is still at 0, so that's 0.02. If the y-intercept is 5, then the y-intercept point will be 0, 5. Let's look at that one. Here it's crossing at 0.5. So it's still 0 on the x-axis, but it's 5 on the y-axis. So that's 0.05. So at the y-intercept, the x-coordinate will always be 0. And by the way, this point here, let me grab my spotlight, this is the x-intercept. And the y value will always be 0 at the x-intercept. Here's another x-intercept for this line, and this is the x-intercept for the proportional relationship. So just the opposite when you're talking about the x-intercept. We're talking about the y-intercept. B is always the y-coordinate where x equals 0. Very important point. Oh, I must have missed my, interactions. Investigating slope and y-intercept in an equation. Y equals -2/3 x plus 4. See what else is going to pop up here. Oh, that's kind of messy, huh? Okay, M is your slope. B is your y-intercept. So then we figure out slope is y2 minus y1. We know this already. x2 minus x1. Or if we have a graph, rise over run. So 0.04, I'm just wondering if I had some points. What is the slope of this linear equation? Well, it's 2 over -3 or -2 over 3. So I just wonder if I had, let me just hit escape once and see if something's underneath that yellow box. I'll be right back. Okay, so I fixed the animations in this slide so that it would make more sense. So here we go. So investigating slope and y-intercept in equations. Here's our equation. Y equals -2/3 x plus 4. So what is the slope of this linear equation? Did you say the number in front of the x, -2/3? Why is that? Because here's our equation. Y equals mx plus bm. The coefficient in front of the x is always the slope. So that is our slope, -2/3 x. Let's prove that 2/3 or -2/3 is really the slope. Well, our slope formula, like we said, is rise over run, or y2 minus y1 over x2 minus x1. Here is the graph of this line right here, and you guys are going to be able to do these graphs as well. So the y-intercept is at 0.04. Notice how x is at 0 and 4 is where it crosses the y-axis. 1, 2, 3, 4. So that is our B up here. So that is how you figure that out with the equation. Here's another point on the graph. I just found a point that actually intersected two lines, and I got point -36. So 1, 2, 0, 1, 2, 3, and then -6. It's actually off a little bit. My dot is, but it should be over 1. And then we will figure out the slope. So 6 minus 4, y2 minus y1 over x2 minus x1. 6 minus 4 is 2, -3 minus 0 is -3. That gives us -2/3, which is what we have up here for our slope. -2/3. I'm just moving this up a little bit so that I have a little bit of room. Okay, and let's try 0.60. Let's see if I got that one right. 1, 2, 3, 4, 5, 6. Yes, this is 0.60. Let's figure out the slope between that and the -3, 6 point. So our y values, 6 minus 0, our x values, -3 minus 6. You subtract, you get 6 over -9, because remember, -3 minus 6 is really -9. It's like -3 plus -6. And then we reduce that, we get -2/3. Yay, that's our slope. So that worked out. So we did that right. My graph is a little bit slightly off, because that should be tipping down just a little bit more to hit this point. Okay, now the slope or the rate of change, which is what slope is always constant. It's the same no matter what point on the line you choose. What is the value of y when x equals 0? This is your x-intercept. What's the value of y at that point? Y is 0, right? Oh no, I'm sorry. They want to know what the value of y is. So they want to know what the value of y is when x equals 0. So here's x equals 0. This is the x-intercept. This is your y-intercept. When x equals 0, go out the line. Y equals, what is that number? 1, 2, 3, 4. Should be 4, right? Yes, so y equals 4 when x equals 0. Remember, that's the y-intercept. X is always 0 at the y-intercept. And y is always 0 at the x-intercept, just the opposite. So kind of wrap your head around that a little bit. Hopefully my animations are going to continue here. Looks like I just forgot that one slide to put animations in there. Okay, linear equation forms. There are different forms for a linear equation. Linear equations can be written in the form of slope-intercept. That's the one we're going to be working with mostly. Y equals mx plus b. So you get very familiar with that. But you can manipulate this algebraically to get different formats for this equation. So in this format, m is the slope. It's very easy to find it. And b is the y-intercept. So it's very easy to find. X and y are points that lie on the line of the graph. Here's the standard form of the same equation. ax plus by equals c. A is a coefficient number, b is a different coefficient number, and c is a constant. So it's the same equation, just manipulated algebraically. So in this case, if you're given this equation, the slope is going to be the opposite of a over b. So if a was, let's say, for example, let's say we had 3x plus 4y, I don't know, equals 10. Okay? In this format, you don't have it, you can't tell what m is right away, but the shortcut is negative a over b. So the opposite, so a is 3, because that's a number in front of x. B is 4, because that's a number in front of y, and then you take the opposite. The negative sign means you take the opposite. So the slope here would be -3/4. The y-intercept is not as easily to determine in this format, and x and y are still points that lie on the line of this graph. We will work with that a little bit, just not right now. We'll work with that a lot next year. Okay, point slope form, you're going to be working with this quite a bit in high school mostly. This is the same equation written this way, y minus y1 equals m times x minus x1. We know that m is the slope, and x1 and y1 is a point on the line of the graph. Waiting for the black bar to go away there. The y-intercept is not as easy to determine in this format either. So our best format for determining all this stuff is the slope-intercept form. And these other two forms can be manipulated algebraically to get you back to the y equals mx plus b format. This point slope form is going to be used a lot when you start doing equations of circles and parabolas and all those good fun things. Any of these formats, like I just said, can be manipulated algebraically and rearranged into any one of the three formats. In 8th grade, we will work mainly with the first one, slope-intercept form. Okay, it's your turn to answer some questions. I'll see you back in a moment. Okay, hopefully you paused the video, did your questions for your turn number 1, and now we're starting on the second portion. Finding slope and, what does that say? Starting values, y-intercept from tables, okay? A phone salesperson is paid a minimum weekly salary and a commission for each phone sold, as shown in the table. I guess I'll bring the table up here. Confirm that the relationship is linear and give the constant rate of change, slope, right, and the initial value, the y-intercept. The initial value is where x equals 0. So we don't have x equals 0 on our table, but we could get it, right? We could go backwards and think about it, right? This is going up by 10s. So if we did the next one backward, that would be 0. And what would this one be? That would be kind of, so you got to figure out how much these are going up by. But there's a better way. So confirm that the rate of change is constant by finding the slope between each pair of points. Okay? Remember, slope is y2 minus y1 over x2 minus x1. So I'm going to pick point 10, 480, and 2630 and check. Okay? You're going to get really good at doing the slope here. So y2, 630 minus y1, 480. These are the y values. And then we have to keep our partners, the x's below. So 20 goes with 630, so that's your x2, and 10 goes with 480, so that's your x1, and it's underneath each other. Then you just do the math. 630 minus 480 and 20 minus 10. Using my calculator, I got 150 over 10. That was my slope. If I was to divide that out, I would get 15 for a slope. Now I have to check the next set of points. So I'm doing 2630 and 3780. 780 minus 630, 30 minus 20 equals 150 over 10, which is equal to 15. So far, so good. The slope is the same. Try the next set of points, 30, 780, and then 40, 930. Again, 930 minus 780 on top, 40 minus 30 on the bottom equals, calculator, 150 over 10, which is equal to 15. So what do we find out? That the rate of change is constant. The slope is constant anywhere on this line from between any 2 points. Okay. Relationship is linear. That means it's a line. The graph of this is a line of this table because the slope is constant. So that's one way of deciding if the graph is going to be a line, because later on you're going to start finding graphs that go like this and graphs that go like this. The sine and cosine graphs go like this, so you'll see that. Those are not linear, right? So those would not have a constant rate of change. The slope would not be constant. And you would know that because look at the slope is going up and then it's going down and then it's going up and then it's going down. So that is not a constant slope. Nonlinear. Okay, let's keep going. I digress. The salesperson received a $15 commission for each phone sold. That's your slope. $15 is the slope or rate of change. So this salesperson got $15 commission for every phone he sold. So he wants to sell you more phones because he gets more money that way. Okay, let's move on. Finding the slope and starting values using tables still. So we have the same equation here, or the same word problem. Okay, so confirm that the relationship is linear. We did that, and we have to give the constant rate of change slope. We did that, found it was 15, and now we have to do the initial value. There's our table again. So now we have to find the y-intercept. Now, I kind of alluded that there's a couple ways of doing this. One is to go backwards and then subtract. So up here, you're going to subtract 10 to get to 0. And here, what are you going to subtract? Well, what is 630 minus 480? I think it was 150, wasn't it? Let's see, 630 minus 480. Oops, I did that wrong. 630 minus 480, 150. I was right. So then we would subtract 150 from that. So that's one way to get your y-intercept. So where the point, so if you subtract 10, you're at point 0. And if you subtract 150 from 480, where would you be? 480 minus 150, 330. So where where x is 0, y is 330. So that is your y-intercept, because remember the y-intercept is where x equals 0. However, I'm going to show you the algebraic way. So the slope m is 15. Okay. So we knew that. We calculated it out. So we're going to put the 15 over here. Now, plug a point into your equation to find b, the y-intercept, because you're not always going to have this fun little table, and it's sometimes going to be very complicated, so you're going to have to know this way. So we can pick any one of these points. We can pick 10, 480. We can pick 26, 30, 37, 80, 49, 30. Any one of these points. So plug a point in. So x is going to be 10, y is going to be 480. So let's do that. I'm putting 10 in there for x, and I'm putting 480 in there for y. Why did I pick that point? It's just got the smallest numbers. So now I have to solve this equation for b. So my first step is going to be to multiply 15 times 10. So 480 equals, what's 15 times 10? 150 plus b. Now we have to solve this equation and get b by itself. Do you remember from last year? Probably not, a long time ago. How to get a variable by itself? Well, you're going to have to subtract. So we have 150 positive, so we're going to have to subtract 150 negative. But whatever we do to one side of the equals, we have to do to the other side of the equals. So we're going to be subtracting 150 from both sides. Notice how if we do that, these are going to cancel out and become 0, and it'll just be b by itself, which is what we want. I'm going to clear that because my computer is going to do it. I have it set up to do that. So on minus 150, we're also going to minus 150 here. We do that, this becomes 0, and we have b on this side. What do we have on this side? 480 minus 150 is 330. Notice how that's the same as what I did up here. I subtracted 150 from 480, and I got 330. Okay, now that's b. So b is equal to 330. So that is our y-intercept. So I put it in up here. I was just trying to see where did that pop up. So I put it in right here. That's your B. The initial value, y-intercept, is $330. Initial means beginning. So the beginning value, where x is 0, is $330. So this salesperson, in the context of this problem, receives a salary of $330 each week before his commission. So he's a guy that he gets $330 check every week, no matter what. And then if you come in and buy a phone from him, he gets $15 for you buying that phone. So if 2 people buy a phone from him, he gets $30, right? 3 people buy it, he gets $45 plus his regular salary of $330. That's how sales commissions work. Okay? Y equals 15x plus 330 is the equation of this linear relationship. Okay, is weekly paycheck, $15 times the number of cell phones that he sells. That's his commission. Okay, next page. Find the slope and y-intercept of the line represented by the table below. Here's our table. There's some x values, we have some y values. We want to find the slope, and we want to find the y-intercept. Since these numbers are smaller and they're even, they're not integers or fractions or any of those things, it's easy to just work backwards, right? If we wanted to, which would mean these go up by 2. So if I subtract 2 from 2, I get my 0 for x. These are going up by what? 10s, right? So if I subtract 10, going backwards, I would get 12. So 12 should end up being our y-intercept, but let's do the work so we can learn how to do this. Okay, step 1, find the slope. y2 minus y1 over x2 minus x1. So we're going to use all these points. Okay, so 432 is one point and 222 is another point. Plug it into the formula, do the math. It's 10 over 2. Then divide that, we get 5. That's your slope. Okay, the slope is equal to 5. Y equals mx plus b. We know what m is. It's 5. See how I put it in there? Okay, now we have to figure out what b is. Well, we can pick any point in this table and plug it in for x and for y. So that's step 2. Plug a point in your equation to find b. So I'm using 2, 22, that point, 2, 22. So 2 is my x, 22 is my y, and now I solve. So I do 5 times 2 first, that's 10. So I have 10 plus b, and then 22 stays 22. Now, how do I get rid of the 10 on this side so that b is all by itself? I subtract 10 from both sides. So subtract 10 from both sides. These 10s will cross off, and I'll be left with 0 plus b, right? And then on this side, it's 22 minus 10, which is what we did up here. We got 12. So b is equal to 12. That is your y-intercept. Okie dokie. What's the equation for that line? Well, here's 12. What's the equation? Y equals the slope 5x plus the y-intercept 12. That means that this line, if you were to graph it, is 12 units up from the origin 0, 0. It has shifted up 12 units. And it has a slope of 5. Slope equals 5, y-intercept equals 12. Oh, let me clear this. Okay, you get a turn to give this a try. See you back in a moment. Okay, welcome back. It looks like my animations are a little off again, but we'll get there. So how to derive the slope-intercept form of an equation. So this is how this works. This is why this works. So let's follow along with me. Let L be a line with a slope m and y-intercept of b. Okay? Circle the point that must be on the line. So b 0, 0 b, 0 m, or m 0. So it's line L. So the line, I don't know if it goes this way, if it goes that way, if it goes that way, but it's called line L. Okay? It has a slope at m, so whatever the slope is, it's m, and the y-intercept is where it crosses the y-axis somewhere. So if it's here, that's the y-axis, right, compared to there, wherever. So which point must be on the line? I hope you know which one of these. Where the y-intercept is always where what? X equals 0, right? And then y is equal to the b. So that is the point on the line. So hopefully that'll circle it for us. Yep. Okay. Let's keep going. We know that the y-intercept is where x equals 0 and y equals b, whatever b's value is. Find the slope using point 0b and point xy. So we're just going to plug it into the formula. We have our y2 minus y1. We'll look at this. So this is 1 point. Even though it's a letter, don't worry about that. Let's see. So y2 will make this point y2. We'll make this point y1. And this would be point x2. And this would be point x1, right? So let's see how I did the animations for this. Slope, there's your formula. M is equal to y2 value minus b, the y1 value, over x, the x2 value, minus 0, the x1 value. Okay, so far so good. What is that equal to? Well, x minus 0 is just going to be x, isn't it? So now we have y minus b over x. So now, this was already there because I forgot to put that animation in, but m now is equal to y minus b over x. And I have to get y by itself, right? Because I want to get the slope-intercept form where y equals mx plus b. So I'm going to multiply by x, and these two are going to cross off, right? These two here are going to cross off if I do that. So I have to do the same thing to both sides. So if I multiply by x here, I got to multiply by x on this side. So I think my animation should do that. Yes, so now I'm multiplying by x on both sides. The x's on the right are crossing off. And now on this side, I have xm, but I rewrote it as mx. Doesn't matter which order you put it in. So I put it in mx because that's what we're used to seeing. Equals, and now we just have y minus b left because these x's crossed off. We're almost in the right format now. What do we have left to do? Well, we have to get b on the other side of the equation. So how do I do that? I'm going to add b to both sides. If I add b to both sides, these two b's are going to cross off because negative b and positive b just makes 0. So let's cross them off. And now we're left with y equals, and on the other side, mx plus b. It's just in backwards order, right? So we can just switch it around and say y equals mx plus b. So that is where we get the slope-intercept equation. Okay? Go back, and I encourage you to go back and watch this video or do these slides. I'm sharing the slides with you. I would like you to go back and look through these again. There's a lot of information here. Okay, that is it. And I will open my screen and show you. Okay, I'm going to say goodbye to you. And like I said, I encourage you to go back and look at this video again and or look at the slides because there's a lot of good information, stuff you're going to need. Bye.